Okay, in this video I'm going to do problem 3 from homework number 2, and in fact, due to the numbering of this homework, this was the first problem of that homework set. So it says to use the rules of logic to show that each of the equalities hold, and so in each case I need to show that the left hand side equals the right hand side. So I'm going to start with part A, and I'm going to show that this left hand side is equivalent to P. And I'll do that by starting with the left hand side and noticing that I can use the distributive law and factor out. I'll copy the statement here, P or not Q, and P or Q. So this is the left hand side of part A, and I'm going to try to show that this is equal to P. And what I'm going to do is I'm going to see that I have P or that can be factored out. And that will leave me with a P or, and then not Q and Q. Not Q and Q, like that. But now I've got one of our standard things that we can see here, that this is a contradiction. So this is P or 0, and anything ORed with 0 is itself. Okay? If P happened to be 1, then I had 1 or 0, and that comes out to be 1. And if P happened to be 0, then I'd have 0 or 0, and that comes out to be 0. In either case, the P ORed with a 0 comes out to equal P. Okay? So that's part A. Part B is going to be very similar, except I'm going to have to do a De Morgan's first. So let me do part B starting up here. And I have not P and not Q, and not Q or P. And that's the left-hand side of part B. First thing I'm going to do is apply De Morgan's to this side over here on the left of the and. And I'm going to take this minus sign, or this negation, and move it in. And I'm going to double negate each of these, the P and the Q, and I'm going to change the and into an or. And this is going to come out to be P or Q, and now the rest not Q or P. Okay. And so I first applied De Morgan's, and then I'm going to apply the commutative rule to the not Q or P, and write P or not Q. And once I've done that commutative rule, I can identify the P or, which can be factored out. P or Q and not Q. So when I factor out the P or, I'm left with Q and not Q. And that works. And now I'm back to exactly what I had in part A. P or 0, which is equivalent to P. Okay. Let's see. Part C I think I'll do on a new page. It's not Q and P or P and Q. Part C is not Q and P or P and Q. And that's the left-hand side. Let's just double check that. Not Q and P. Yep, okay. Or P and Q. Oops, I'm all the way on page 3. Okay, I'm going to do, I guess I'll go ahead and use the commutative rule first here, but one way or the other I have a P and here, and I'm going to factor that out. So I'll go ahead and commute the first and statement like that. And then I've got the P ands written so that I can factor them out, not Q or Q. And now I have P and now this is a tautology. Either Q is true or it isn't. So one of these two is going to be true either way. If Q is true, then the one on the right is true. If Q is false, then the one on the left is true. In either case, the OR statement becomes true, and I have a tautology. We also have P and 1, and that is indeed equal to P. And if in case P is 0, we have 0 and 1, which is 0. And in case P is 1, we have 1 and 1, which is 1. In either case, P and 1 is equal to P, either 0 or 1. Okay, finally for part D, let's see if I have room over here to do it. And now I have to look at what it looks like. Oh boy. P and the quantity, Q and R or Q and not R. P and the quantity, Q and R or Q and not R. Oops, what did I just do? I'm trying to draw another parenthesis here and I did something. Okay, well, you're going to see a familiar pattern here. We have Q and, which can be factored out. And we just have to keep track that P is ANDed with this whole big thing that I'm working with here. And so I have a Q and I have R or not R. So I have P and. Now just a second here. I've got P and, I've got two AND statements in a row, and so I don't need the parentheses any longer. I have P and Q and. Now R or not R is a tautology. And anything ANDed with a tautology is itself. And so the thing I have ANDed with the tautology is that P and Q. And so I've shown that the left-hand side is equal to the right-hand side, P and Q. Okay, you'll see the familiar pattern in all of these. Mostly it's something to do with factoring out and then getting either a tautology or a contradiction here. And maybe you have to use a De Morgan's law. Maybe you have to keep track of some extra stuff along the way, but they all follow that same basic pattern. So that's problem number 3, the first one from homework 2 this semester.